Everyone, this is Dr. Nick Carr, who's the founder and data architect of KurrawongAI, who are currently developing tools and methodologies for the improving Indigenous research capability focus area. And Nick's going to be talking to us about fuzzy geometries for mapping imprecise regions, which is some very unique and valuable work they've been doing in the context of Indigenous data. And I'll let Nick take it from here.
Thank you very much. Yes, this is work that's part of our Indigenous data network work within the project. But it's got applications elsewhere too, which I'll also show. Okay, now I just want to share my screen, and I can just see the corner of my screen, so I believe it's coming through okay.
Yes, Nick, we're all good.
Great, excellent. Okay, all right, well, let's get into it. So why do we need a fuzzy geometry model? And I want to stress the word model here. We need a model of these things for particular reasons. How does it work, and when can I get my hands on it? So pretty straightforward. Okay, so why do we need a model? Well, not all spatial regions are defined crisply. This is certainly true in the Indigenous space, but it's also true in many other spatial spaces. So lots of times we have areas that are just not well defined by a point or a very neat polygon. So the question I ask to demonstrate this is, where are the Glasshouse Mountains? Now, there's a locality in Queensland called the Glasshouse Mountains. You see it on the map there. That's just north of Brisbane. And looking at this, you think, oh, there's the Glasshouse Mountains. Very nice, neat polygon, brought to you by the Queensland government, job done. Well, not so easy, because the mountains themselves, known as the Glasshouse Mountains, are not just in that region. They're also south of the region, where you can see those dots, and here, there, and everywhere. So if you were to say the Glasshouse Mountains, firstly, do you mean the locality as specified by the government, or do you mean something else? If you mean the general area of the Glasshouse Mountains, it's clearly not that locality. That's just not a good representation of the Glasshouse Mountains. So maybe you could just say, well, this whole area is the Glasshouse Mountains. It includes a formal government locality, but it includes the general notion of the Glasshouse Mountains. And you can draw a big purple circle like this and say, job done. But again, that's not really great, because what about a bit of nuance? How do I know when something precisely in or out of this area? So there's all these kind of issues. So this is what I think we should really be doing. If we wanted to say, where are the Glasshouse Mountains? It's where that purple is. It's definitely in the middle of all of those mountains. Everyone would say that that's definitely sort of ground zero Glasshouse Mountains, but heading out in different directions, maybe it's the Glasshouse Mountains, maybe it's not. Now I'm using the Glasshouse Mountains. You could pick many different kinds of areas and regions for this. I just happen to be using what I think is a fairly uncontroversial one here. So this is what we want to draw. We want to draw a picture that looks like this, that says this is the Glasshouse Mountains. It's fuzzy, it's not precise, it has deliberately inbuilt imprecision. Begone false precision, I say. So some non-crisply defined HASS-I types of regions, Indigenous language regions. Obviously, the map on the screen at the moment has got space-filled polygons that indicate areas of spoken Indigenous languages. But of course, in reality, these areas overlap. They're not precise. Cultural landscapes are often not precisely definable. Historical areas, and then outside of the HASS-I space, we've got things just from other sectors like resource occurrence. Where resources occur is not precisely clear-cut defined. Grades of mineral ores and things like that lend themselves to fuzzy representation. And in the environmental sciences space, species distribution, koalas don't precisely go to this spot and end. They kind of mill about and go to different places. And the likelihood of seeing a koala here versus there, changes over a gradient. Okay, so why do we need a model? We might accept that we could do better at displaying areas as fuzzy things, but don't GIS systems handle fuzziness already? Can't we just put a polygon into a GIS system and kind of blur it a bit? Doesn't that get the job done? So why do we need a model in particular, a formal model? Well, perhaps GIS systems do handle some versions of fuzziness, but just consider the area known as Southeast Queensland. And this is an example I showed to the National Place Names Working Group recently. Southeast Queensland, as I've got it there on the map, and again, I've just made up my representation of Southeast Queensland, but we know that it's definitely not in New South Wales. It's definitely not in the sea. But to the west and to the north, it's not obvious where Southeast Queensland ends. Different people have different ideas about this. It's very difficult to draw a an area in a GIS system like that picture there, where you've got a precise edge here, a precise there, and then varying degrees of blurriness in different directions. In addition to that, GIS systems that do allow fuzzy representations of areas, they all do them differently. So if I have an area and I put this into ArcGIS Pro and I blur it, and then I give that to someone else, if I give them an image, sure, it stays like that. But if I give them the data, they're going to blur that data differently, and it's not going to look the same as what I started off with. So if a data originator, say an Indigenous group, wanted to represent an area as a fuzzy area, they don't really have a means of providing that area to different tools and organizations using tools in a way that stays kind of the same. So we need a formal model. And before I go into the mechanics of the model, what having a model allows us to do is to agree on the terms under which we actually represent fuzziness. So if we have a model, then we can say that tools should respect that model, and they should always display content in the way that the model specifies. And that's what this model does. So the model is a formal data model, and I'm going to go through just a couple of aspects of the model and then show where we're up to with actually using it. So this is how it works. It's very simple, actually. The model uses a collection of geometries rather than just one geometries to represent an area. It uses a collection of related geometries, so a geometry collection. Oops, I'll just go back a couple of slides. And it does things like this. You can see here, this is an area sort of central Brisbane. And it's got 1, 2, 3 polygons there. The dark blue one in the middle is definitely Brisbane. The next one is probably Brisbane, and the third one is likely Brisbane. And the model uses all 3 of those to represent the area, and then it does some trickery to make it look nice. So we'll come to that in a second. So what we can do is, taking those 3 areas, we can actually kind of blend or smooth or blur in different directions, not at the same rate, at a rate that's set by the differences between those different geometries. So if we want precision in one direction, we can coincide the geometry's boundaries. If we want to blur smoothly, we can stretch them out in a certain direction. So that would allow us to draw a picture like that Southeast Queensland I showed before. This is the kind of thing that we can get the actual tool to do. So there you go. So I think that this is Brisbane, right? And again, I've just sort of made this up, but you can see that on the map there, the dark blue bit, definitely Brisbane. Down at Logan City, is Logan City Brisbane? I mean, maybe it's not, but it's within the blur. So probably, according to this picture, it could be. It's probably the answer. So there are different levels of measurement between those multiple polygons that are used to define an area. And I'm not going to go into the details here, but I welcome people who are interested in the mechanics of the model to read through that. Basically, we can determine whether the areas given in different polygons must be met exactly by representations of a fuzzy area, or whether they're a guide, whether the tools that do the blurring are allowed to blur to 0, like nothing, or 100%, or whether they have to hit some other marks. So there's a bit of sophistication in the way that the multiple geometries are related to achieve different visual and calculation effects. The model allows for different lines of evidence. So if we say, as I said before, this is the Glasshouse Mountains area, the one line of evidence for where the Glasshouse Mountains might be would be the location of the mountains themselves. But another line of evidence might be, traditional use of the name, or the Glasshouse Mountains. Certainly, the city locality is also some evidence for that being the area of Glasshouse Mountains. And in Indigenous context, we can say there might be a linguistic evidence for a particular area. There might be an archaeological evidence. There might be a current cultural sort of line of evidence as well. So we can we can create different representations of an area, bring them all together, and then create a fuzzy area from those, where all those different areas have different lines of evidence. The lines of evidence might also be numeric. They might be derived from satellite imagery or following calculations, but they can also be these narrative ones. And it's the narrative ones that matter most, certainly in our current Indigenous work. Now, another aspect of this work is that because we're representing these fuzzy areas as a fancy geometry collection, we can slot them into models for place names and addresses. And this is, of course, very important for Indigenous place naming and so on. So just taking the Glasshouse Mountains as an example, at the moment, the Queensland government is capable of producing a model like this, where the Glasshouse Mountains is a name for an area of ground, a geological, or if not a geological, a geospatial feature, and that feature has a geometry, either a point or a polygon. But going forward, that geometry can be this geometry collection, and it can be defined by that blurred area. So we can retain all of the information about place naming, but the things that we're assigning it to can now be made a bit more fancy, a bit more true to reality. Probably the last aspect I'll talk about for the actual technicals of the model is how does it actually, well, I should just state, it allows for probabilistic calculations of things being in and out of areas. So again, taking that Glasshouse Mountains example, that red cross in the middle of it is almost certainly in the Glasshouse Mountains area. That second one towards the left is quite likely in the area. You can just see this visually. And the third one is perhaps in the area. Now that's our visual estimation of those things. But when we do calculations with an area specified as a fuzzy geometry, we can actually get numbers for these things. So we might get, the number 0.9 for the almost certainly, maybe the quite likely is 0.6, and the perhaps in is something like 0.2. But we can actually do topological spatial functions and get actual specific uncertainty numbers for things like this. And this is really going to be really useful for Indigenous areas when people say, is this proposed mine site in such and such a cultural area? Well, probably, or it's likely that it is, or it's unlikely that it is, rather than yes or no. And yes or no is very unhelpful for fuzzy areas. Oops. So the last slide is just when can I get my hands on it? Well, the specification is actually online now. That's the link to it there. The display software that rendered that Brisbane area and that does a few other bits and pieces, we've actually produced a first version of that in the project, and we're about to deliver that tools capability into the Indigenous Data Network spatial demonstration catalog. So we have a catalog of Indigenous areas. They're all either points or polygons at the moment, but we're going to start to load that catalog with demonstration areas, and we're going around now looking for data to fill it with real Indigenous areas. And when you go to one of those places, you'll actually see it in those fuzzy visual terms. Again, the information is actually stored in a precise model mechanism behind the scenes, but we can display it as a fuzzy thing. We can do calculations with it, etc. So in the first quarter of next year, so January, February, March, we should have some good demonstrations of small areas, big areas, complicated areas, simple areas, all of them using this fuzzy geometry mechanic. And we have high hopes that this will empower Indigenous communities to share more spatial information, knowing that uncertainty can be added to it, that imprecision can be added into the data and preserved, and that their intentions for display can be encoded in the data and then handed over to different organizations. They don't have to give an organization a precise area and saying, by the way, please, when you display this, can you blur it? They can actually embed that blurring in the data itself. That's it. Thank you to the ARDC's project for funding this work, of course. And we do hope, as I mentioned, that this work will empower Indigenous users of spatial data and also other users potentially, like place naming authorities as well.
Okay. Thanks so much, Nick. Does anyone have any questions really quickly? Just 2 minutes. Got a question at the back.
Thank you. Thanks, Nick. That was great. I'm just wondering if you've had any thoughts about the intersection between spatial and temporal data and whether it would be, there's the potential to extend this so to reflect the fact that, say, local government areas might change or cities grow throughout time, so the area that they take up is broader, or registered Aboriginal party boundaries might change, that sort of thing.
Sure, and I'm assuming that my response can be heard okay. Yes, look, the fundamental model that's under the hood that relates features to geometries that we've now added this fuzzy capability to, that is following a set of international spatial data models, which in a parallel set of work to this, we've also been, tidying up the relations between spatial and temporal. So, I just didn't go into this presentation, but in fact, the same fuzziness which we can have in sort of 2D and even 3D in spatiality, we can actually have that in temporal extents as well. So we can use temporal relations. We can say this event definitely occurred within that larger event, or maybe it occurred within it, or and so on. So we can do fuzziness in temporality, and we can relate spatiality and temporality together. So yeah, you could imagine an area that is both fuzzy in space and time, and we already have the technical capability to represent that, but we don't have the technical capability to display that yet. So we'll do the spatiality in time fixed areas to begin with, and then you can imagine slider bars that grow and change these fuzzy areas.
That was a great answer, Nick. So yeah, thank you everyone. Please thank Nick. This has been a fantastic presentation. And if you want to follow up with him or the ARDC project, IRDN, find out a bit more about how this is being deployed into the future. And let's invite the next presenters up.